The morning of November 11th, 1943, marked the combat debut of what would become the United States Navy's most controversial dive bomber. As Squadron VB-17 prepared to launch from the flight deck of USS Bunker Hill toward the Japanese fortress at Rabaul, few could have predicted that the aircraft they were about to fly would require 880 modifications before the Navy deemed it combat-ready. The Curtiss SB-2C Helldiver, destined to be nicknamed the Beast, or Son of a Bitch Second Class, and worse, was about to begin a combat career that would see it sink more enemy ship tonnage than any other Allied dive bomber, including the mighty battleships Musashi and Yamato. Yet this same aircraft had crashed twice during prototype testing, triggered a congressional investigation, and earned the hatred of pilots who flew it. The story begins not with triumph, but with an impossible set of demands. In August of 1938, the United States Navy issued specifications for a new scout bomber that would push the boundaries of what was technically feasible. The aircraft needed to carry a 1,000-pound bomb internally, possess greater range than the Douglas SBD Dauntless, and fit the strict dimensional constraints of the new Essex-class aircraft carriers. The most challenging requirement was size. Two of the new aircraft had to fit on a standard carrier elevator measuring 40 feet by 48 feet, with 1 foot clearance all around. This seemingly simple constraint would haunt the Helldiver throughout its entire operational life. Raymond C. Blaylock, heading the design team at Curtiss-Wright, faced an engineering nightmare. Unlike the company's better-known designer Don Berlin, who had created the P-40 Warhawk, Blaylock was tasked with cramming modern bomber capabilities into a package small enough for carrier operations. The result was a short-coupled design, one where the distance from wings to tail was unusually brief. This aerodynamic compromise created inherent instability that Blaylock's team attempted to overcome with the aircraft's distinctive large tail surfaces. But the fundamental problem remained. The fuselage was simply too short for the aircraft's size and weight, a flaw that would plague every variant of the Helldiver. On May 15, 1939, the Navy awarded Curtiss-Wright a contract for the prototype XSB-2C1. What followed was a development program marked by crashes, delays, and an ever-growing list of required modifications. The prototype first flew on December 18, 1940, but crashed on February 8, 1941, when its engine failed during a landing approach. Curtiss rebuilt the prototype, but tragedy struck again on December 21, 1941. Test pilot Barton T. Red Hulse was forced to bail out when the aircraft's wing failed catastrophically during a high-speed dive. The sight of the Helldiver's wings separating from the fuselage would become a haunting image for many who witnessed early test flights. Despite these setbacks, the Navy had already ordered large-scale production in November 1940. Over 800 design changes were specified for the production model, including enlarged fin and rudder areas, increased fuel capacity, self-sealing fuel tanks, and doubling the fixed armament to 4 50-caliber machine guns in the wings. As 1942 dawned, Curtiss-Wright faced the monumental task of transitioning from prototype to mass production. The company's decision to shift manufacturing from Buffalo, New York, to a massive new government-funded facility in Columbus, Ohio, would prove to be another chapter in the Helldiver's troubled genesis. The Columbus plant, designed by Albert Kahn Associates, was hailed as a marvel of modern industrial architecture. Covering hundreds of acres, it represented a $27 million investment by the Navy, with an additional $98 million allocated for production contracts. By 1942, the facility employed 21,012 workers, making it one of the largest single-story industrial plants in the world. But size alone could not overcome the fundamental challenges facing Curtiss-Wright. Of the first batch of job applicants, only 2% possessed any experience in aircraft production. These workers were suddenly tasked with building what had been described as the most complex single-engine design of its time. The learning curve was steep, and the consequences were immediate. Margaret Chen, a riveter who joined the Columbus plant in March 1942, later recalled the chaos of those early months. "We were all learning as we went," she remembered in a post-war interview. "The blueprints seemed to change every week. What we built on Monday might be different from what they wanted on Friday." The problems extended far beyond inexperienced workers. Middle management, stretched thin by wartime demands, often proved incompetent. Qualified engineers and supervisors were in desperately short supply, diluted across Curtiss-Wright's rapidly expanding network of facilities. The more plants the government built for the company, the thinner the pool of talented personnel became. Quality control collapsed under the pressure. One Army Air Forces report described the Lockland engine plant as a disgrace to the company and to the Air Forces. The once sleek Columbus factory became what observers called a cluttered, crowded, ill-lit dump. The first production SB-2C-1 finally flew on June 30, 1942. But the aircraft that emerged from the Columbus production line bore little resemblance to the carefully crafted prototype. Manufacturing flaws were endemic, electrical systems failed regularly, and the complex hydraulic system proved unreliable in service conditions. By 1943, rumors of problems at Curtiss-Wright had reached Washington. Senator Harry S. Truman of Missouri, heading the Senate Special Committee to investigate the National Defense Program, launched an investigation that would expose the depth of the company's troubles and contribute to its eventual downfall as an aircraft manufacturer. The committee's findings were devastating. At the Wright Aeronautical Plant in Lockland, Ohio, the largest single-story industrial facility in the world, investigators discovered that more than 25% of engines built at the plant have consistently failed in one or more major parts during a 3-hour test run. More damaging were allegations that Wright was producing and causing the government to accept defective and substandard material by the falsification of tests, by destruction of records, by forging inspection reports. The committee took 1,300 pages of testimony documenting these practices. The SB-2C program came under particularly harsh scrutiny. Despite receiving $27 million for the Columbus plant and $98 million more for production, Curtiss-Wright had failed to deliver a single aircraft the Navy considered combat-ready. Production was supposed to have commenced in December 1941, but didn't actually begin until September 1942. To date, Curtiss-Wright has not succeeded in producing a single SB-2C which the Navy considers to be usable as a combat airplane, the committee reported. The knowledge of the plant's inactivity has become widely known among the friends and relatives of the 21,012 workmen, has had a bad effect upon morale in that area. Adding insult to injury, the committee discovered that Curtiss-Wright had spent $12,448 advertising the Helldiver as the world's best dive bomber, while failing to produce a single combat-worthy example. The investigation's political ramifications extended far beyond Curtiss-Wright. The scandal helped elevate Truman's national profile, contributing to his selection as Franklin Roosevelt's running mate in 1944 and his eventual ascension to the presidency. For Curtiss-Wright, however, the investigation marked the beginning of a decline from which the company would never recover. While American investigators probed Curtiss-Wright's practices, across the Atlantic, the Royal Navy was conducting its own evaluation of the Helldiver. The results would be even more damning than the Truman Committee's findings. The British had initially ordered 450 SB-2C aircraft for the Fleet Air Arm, designating them Helldiver I. These aircraft were intended to operate from British carriers in the Pacific, where the Royal Navy planned to support American operations against Japan. Only 26 aircraft were actually delivered to Britain before the program was cancelled. The Aeroplane and Armament Experimental Establishment at Boscombe Down conducted exhaustive testing of these aircraft, and their verdict was unequivocal: appalling handling. Commander Michael Harrison, the Royal Navy test pilot who flew the Helldiver evaluation flights, later described the experience in his memoir. The aircraft displayed characteristics that would be charitable to call unforgiving, he wrote. Lateral stability was virtually non-existent at low speeds, precisely when a pilot needs it most for carrier operations. The British evaluation was particularly harsh regarding the aircraft's carrier landing characteristics. The Helldiver's poor aileron response below 90 knots made it dangerous to fly during the 85-knot approach speed required for carrier landings. Combined with the aircraft's tendency to bounce rather than settle on the deck, this created an unacceptable risk for Royal Navy operations. Squadron leader James Patterson, who observed the trials from the Royal Australian Air Force, noted that the aircraft seemed to actively resist pilot inputs at precisely the moments when those inputs were most critical. The bounce characteristics that prevented the tailhook from engaging properly resulted in multiple barrier engagements during the brief evaluation period. The Royal Navy's rejection was swift and absolute. None of the 26 aircraft delivered to Britain were ever used in combat operations. The remaining 424 aircraft on order were cancelled, representing a loss of millions of pounds in contracts but potentially saving British aircrews from an aircraft deemed unsuitable for operational service. The cancellation sent shockwaves through Curtiss-Wright's management. Losing such a large international order was bad enough, but the public nature of the rejection and the reasons behind it damaged the company's reputation with other potential customers. The Royal Australian Air Force's experience with the Helldiver proved equally disappointing, though for different reasons. Australia had ordered 150 aircraft designated A-25A Shrike, the land-based variant intended for the U.S. Army Air Forces. By the time the first 10 Shrikes arrived in Australia in November 1943, the Royal Australian Air Force had already decided that dive bombing was an obsolete tactic. The Vultee-Vengeance dive bombers already in service were being replaced by more versatile light bombers capable of multiple mission profiles. Only one of the 10 aircraft delivered to Australia A-69-4 ever flew operationally. Assigned to No. 1 Air Performance Unit, it conducted performance testing between December 1943 and April 1944. The remaining 9 aircraft were transferred to United States Army Air Forces units in the Southwest Pacific Theater by mid-January 1944. Flying Officer Robert Mackenzie, who flew A-69-4 during the evaluation period, later recalled that the aircraft's handling characteristics were challenging but not insurmountable. However, he noted that, by the time we received the aircraft, our tactical doctrine had evolved beyond the need for dedicated dive bombers. The Australian experience highlighted a broader shift in military thinking. While the Helldiver was designed to fulfill traditional dive bombing roles, the war had evolved beyond these narrow mission parameters. Multi-role fighters like the F-6F Hellcat and F-4U Corsair could carry similar bomb loads while offering superior air-to-air capability and easier maintenance. A-69-4 was eventually transferred to the United States Army Air Forces in December 1944, ending Australia's brief flirtation with the Helldiver. The remaining 140 aircraft on order were cancelled, another blow to Curtiss-Wright's international sales efforts. Despite the setbacks and investigations, work continued at the Columbus plant throughout 1943. A revolution was taking place on the factory floor, driven not by management directives, but by the determination of workers who refused to accept failure. Among these workers was James Washington, an African-American machinist who had migrated from Mississippi to find work in the defense industry. Washington later recalled the atmosphere of those critical months. "We knew the boys overseas were counting on us. Whatever problems the company had, we weren't going to let them down." The workforce at Columbus reflected the broader social changes occurring across America during World War II. Women comprised a significant percentage of the assembly line workers, taking on roles traditionally reserved for men. African-American workers, previously excluded from many industrial jobs, found opportunities in the defense plants that had been denied to them in peacetime. Dorothy Martinez, a Mexican-American woman who worked as an electronics installer, remembered the complexity of the Helldiver systems. "That plane was a jungle of wires and hydraulic tubes," she recalled. "The hydraulics operated everything: flaps, folding wings, landing gear. When something went wrong, it usually went wrong in a big way." The aircraft's complexity was both blessing and curse. While it enabled advanced capabilities like internal bomb bays and folding wings, it also created numerous points of failure. Workers on the production line quickly learned to identify potential problems before aircraft left the factory, but the learning process was steep and costly. By late 1943, a parallel production line had been established to modify aircraft that had already rolled off the main assembly line. This unprecedented step reflected the magnitude of changes required to make the Helldiver combat-ready. Aircraft number 601 marked the point where the main production line finally incorporated all necessary modifications, eliminating the need for post-production fixes. The human cost of these production problems was immense. Workers routinely put in 12-hour shifts, 7 days a week, struggling to meet delivery quotas while implementing constant design changes. The physical and emotional toll was evident in accident reports and sick leave statistics from the period. By early 1943, The first production Helldivers were ready for the ultimate test, carrier operations. What followed was a series of trials that nearly ended the program entirely, as the aircraft's fundamental design flaws became apparent under operational conditions. The trials began aboard USS Yorktown, CV-10, under the command of Captain Joseph J. Jocko Clark, a tough Texan known for his no-nonsense approach to naval aviation. Clark had extensive experience with carrier operations and was not easily impressed by new aircraft. His initial encounters with the Helldiver left him convinced that the program should be terminated. The aircraft is entirely unsuitable for carrier operations, Clark reported to his superiors. The Helldiver's tendency to bounce upon landing prevented the tailhook from engaging with the arresting cables, sending aircraft careening into the steel barrier cables stretched across the flight deck. Multiple aircraft were damaged or destroyed in barrier engagements during the brief evaluation period. Lieutenant Commander William Hayes, the squadron commander overseeing the trials, kept detailed notes on each landing attempt. Aircraft exhibits severe longitudinal instability at approach speeds, he wrote. Pilot workload is excessive during the critical final approach phase. Recommend immediate suspension of carrier operations. The structural problems were even more alarming. Several aircraft experienced wing failures during diving tests, echoing the prototype crashes that had plagued the program from the beginning. When aircraft number Buno 17740 broke apart during a dive off the Virginia coast, killing both pilot and radioman, many thought the program was finished. Captain Clark was so concerned about the aircraft's safety that he recommended reverting to the Douglas SBD Dauntless. Despite that aircraft's age and limitations, I would rather send my pilots into combat with a reliable aircraft than risk their lives with an experimental one, he told a board of inquiry investigating the crashes. The near-disastrous carrier trials led to another round of modifications. The fuselage was lengthened by 1 foot to improve longitudinal stability, and the tail surfaces were redesigned to enhance control authority. Structural reinforcements were added throughout the airframe to prevent the wing failures that had claimed several aircraft and crews. Despite official skepticism and continued problems, a dedicated group of pilots and maintenance personnel worked to unlock the Helldiver's potential. Their efforts would eventually transform the aircraft from liability to asset, though not without considerable cost in time, resources, and occasionally lives. Among these pioneers was Lieutenant Commander James Vose Jr., commanding officer of VB-17, the first squadron to receive operational Helldivers. Vose approached the aircraft with the methodical mindset of a test pilot, carefully documenting its characteristics and developing procedures to work around its limitations. Every aircraft has its peculiarities, Vose told his pilots during training sessions at Naval Air Station Wildwood, New Jersey. Our job is to understand those peculiarities and use them to our advantage. This philosophy would guide VB-17 through the aircraft's combat debut and subsequent operations. The squadron's maintenance chief, Senior Chief Petty Officer Michael O'Brien, became an expert in the Helldiver's complex systems. With 30 years of Navy service, O'Brien had maintained everything from biplane fighters to the latest carrier aircraft. He considered the Helldiver the most challenging aircraft he had ever encountered. The hydraulic system was the heart of the beast, O'Brien later recalled. When it worked properly, you had an aircraft capable of remarkable performance. When it failed, which happened more often than anyone wanted to admit, you had a very expensive paperweight. O'Brien's team developed innovative maintenance procedures to keep the aircraft operational. They learned to identify potential hydraulic failures before they occurred, developed workarounds for common electrical problems, and created modification kits to improve reliability. Their work often continued long into the night, ensuring that aircraft were ready for the next day's training missions. Pilot training evolved alongside maintenance procedures. The Navy established specialized schools to teach the unique characteristics of Helldiver flying. Unlike the forgiving SBD Dauntless, the Helldiver demanded precision and constant attention from its pilots. A moment's inattention during approach could result in a barrier engagement or worse. Lieutenant William Clank, who joined VB-80 during its formation in early 1944, remembered the intensive training required to master the aircraft. It was not a forgiving airplane, he recalled years later. You had to learn it, really understand its moods and characteristics. But once you'd gotten it, the Helldiver would serve you well. The training regimen was exhaustive. Pilots spent hours in ground school studying the aircraft systems, practiced emergency procedures in link trainers, and flew countless hours perfecting their techniques. The washout rate was higher than for any previous Navy aircraft, reflecting the Helldiver's demanding nature. November 11th, 1943, marked a pivotal moment in both the Pacific War and the Helldiver's troubled history. Squadron VB-17 aboard USS Bunker Hill, CV-17, was about to launch the aircraft's first combat mission against one of Japan's most heavily defended positions, the fortress at Rabaul. Rabaul represented the cornerstone of Japanese defenses in the Southwest Pacific. Located on the island of New Britain north of Papua New Guinea, the base complex housed over 100,000 Japanese troops, multiple airfields, and extensive anti-aircraft defenses. Intelligence estimates suggested that attacking Rabaul would be like kicking a hornet's nest. The response would be swift and deadly. The morning of November 11th dawned clear and calm, perfect conditions for the massive strike planned against Rabaul. Task Force 38 had assembled the largest carrier force yet seen in the Pacific. USS Saratoga, USS Princeton, USS Bunker Hill, USS Essex, and USS Independence, carrying a combined total of 276 aircraft. Lieutenant Commander Vos led his Helldivers off Bunker Hill's deck at 0900 hours, followed by squadrons of TBF Avengers and F-6F Hellcats. The formation climbed steadily as it headed northwest toward New Britain, with Vos monitoring his engine instruments carefully. The early Helldiver engines were prone to overheating, and the long flight to Rabaul would test every system aboard the aircraft. As the formation approached Rabaul, the defenders were ready. Japanese radar had detected the incoming strike, and anti-aircraft guns were trained skyward. Lieutenant General Imamura Hitoshi, commanding the 8th Area Army, had over 300 anti-aircraft guns of various calibers protecting the base complex. The first waves of fighters swept over Rabaul's airfields, suppressing Japanese interceptors that attempted to rise and meet the attackers. Behind them came the dive bombers, with Vos's Helldivers targeting the crucial Lakunai airfield. The approach required flying through a gauntlet of anti-aircraft fire that one pilot described as a black cloud of death. Vos put his aircraft into a 70-degree dive, the Helldiver's aerodynamic design allowing it to achieve diving angles that would have torn apart earlier aircraft. The target grew rapidly in his windscreen as he aimed for the runway intersection where parked aircraft were most densely concentrated. At 1,500 feet altitude, Vos released his 1,000-pound bomb and pulled out of the dive, his aircraft shuddering under the tremendous G-forces. Behind him, the rest of VB-17 followed suit, their bombs cratering runways and destroying parked aircraft. The precision possible with the Helldiver's diving capability was evident in the concentrated damage inflicted on the airfield. But the mission exacted its price. One SB-2C bellied in off Bunker Hill's bow during the recovery, and only the rear gunner was rescued by a destroyer plane guard. Lieutenant J.G. Ralph L. Gunville drowned when his aircraft sank rapidly, his pockets weighted down with extra rations intended for the life raft in case of ditching. Gunville's death marked the first American fatality in Helldiver combat operations, a sobering reminder that even successful missions carried significant risks. His loss was felt deeply throughout VB-17, where every pilot understood that they too might not return from future missions. The raid's results were impressive by any measure. American forces sank the destroyer Suzanami, damaged destroyers Naganami and 2 others, and destroyed 11 Japanese aircraft. American losses totaled 4 TBF Avengers and 5 F-6F Hellcats in combat, with additional aircraft written off due to damage. More importantly, the Helldiver had proven it could operate effectively in combat conditions. Despite the loss of Gunville's aircraft, the remaining Helldivers had performed their mission successfully, delivering their ordnance with precision and returning safely to their carriers. While American pilots celebrated their successful debut, the view from Rabaul presented a different picture of the Helldiver's capabilities. Japanese defenders had their first encounter with the new American dive bomber, and their assessments would influence defensive preparations for future battles. Commander Masatake Okumiya of the Imperial Japanese Navy was stationed at Rabaul during the November 11th attack. As an experienced aviator himself, he observed the American formations with professional interest, noting the tactics and capabilities of the various aircraft types. The new American dive bombers exhibited remarkable precision. Okumiya wrote in his diary that evening, "Their diving angles were steeper than the Douglas aircraft we had faced previously, and their bomb patterns were correspondingly more concentrated. The pilots displayed considerable skill in their attacks." Okumiya was particularly impressed by the Helldivers' apparent ability to absorb damage and continue flying. Several aircraft had been hit by anti-aircraft fire during their attacks but maintained formation discipline during withdrawal. This resilience would become one of the aircraft's most valuable combat characteristics. Lieutenant Colonel Yoshio Takatsuka, commanding the 204th Air Group's remaining fighters, attempted to intercept the American formation during its withdrawal. His pilots reported difficulty in engaging the dive bombers, which maintained tight defensive formations and were protected by aggressive fighter escort. "The new dive bomber appears faster than previous American types," Takatsuka reported. "Our pilots found it difficult to close within effective firing range before the escort fighters engaged them. This speed advantage, modest though it was, provided an important margin of safety for Helldiver crews during the vulnerable withdrawal phase of their missions." The Japanese assessment of American tactics was equally astute. Ground observers noted that the dive bomber attacks preceded torpedo plane attacks by several minutes, suggesting coordination problems between the different aircraft types. This information was forwarded to other Japanese commanders, who would attempt to exploit this tactical weakness in future battles. Chief Petty Officer Saburo Nishimoto, manning a 25mm anti-aircraft gun position near Lakunai Airfield, later described the attack from his perspective. "The American planes came down like falling arrows," he recalled. "Our guns could not track them once they entered their dives. By the time we could reposition, they were already pulling away." This limitation of anti-aircraft defenses against steep diving attacks was well understood by American planners. The Helldivers' design emphasized diving capability precisely because it offered the best chance of accurately delivering ordnance while minimizing exposure to defensive fire. Following the successful combat debut at Rabaul, pressure intensified to increase Helldiver production rates. The Navy had originally planned for the aircraft to be operational much earlier in the war, and now faced the challenge of making up for lost time while improving quality control. The Columbus plant underwent a complete reorganization in late 1943. New management, brought in after the Truman Committee investigation, implemented quality control procedures that had been notably absent during the early production period. Assembly line procedures were standardized, and worker training programs were expanded and improved. Production supervisor Helen Chong, one of the few women in management positions at the plant, oversaw the implementation of these improvements. Chong had engineering training from the University of Michigan and brought a systematic approach to problem-solving that had been lacking in the plant's early operations. "We treated every defect report like a detective story," Chong later recalled. "Each problem had a root cause, and our job was to find that cause and eliminate it. Sometimes the solution was simple better training, improved tools, clearer instructions. Other times it required design changes that went all the way back to the engineering department. The statistical improvement in quality was dramatic. By early 1944, the percentage of aircraft requiring major modifications after completion had dropped from over 80% to less than 20%. This improvement reflected not just better manufacturing procedures, but also design stabilization as engineers resolved the aircraft's fundamental problems. Worker morale improved correspondingly. Production teams took pride in building aircraft that would not require extensive rework. Competition developed between different assembly lines, with teams posting production and quality statistics prominently throughout the plant. The human side of this production miracle involved thousands of individual stories. Maria Santos, a hydraulic system installer who had emigrated from Mexico before the war, became expert at identifying potential system failures before aircraft left the factory. Her intuitive understanding of the complex hydraulic arrangements prevented countless maintenance headaches for squadron personnel. Robert Patterson, an African-American electrician from Chicago, developed innovative solutions for the Helldiver's notoriously unreliable electrical system. Working with engineering personnel, Patterson created modification kits that improved system reliability and reduced maintenance requirements. His innovations were eventually incorporated into standard production procedures. The night shift, composed largely of women workers, took particular pride in their contributions to the war effort. These workers faced additional challenges, including inadequate lighting and limited transportation options, but maintained production schedules that kept pace with day shift operations. By mid-1944, the Columbus plant was producing over 100 aircraft per month, a production rate that seemed impossible during the dark days of 1942 and 43. This achievement reflected not just improved procedures and training but also the dedication of workers who understood the importance of their contribution to victory in the Pacific. June 20, 1944, would become known as the Great Marianas Turkey Shoot for American fighter pilots, but for Helldiver crews, it represented one of the most costly missions in the aircraft's operational history. The Battle of the Philippine Sea provided a harsh lesson in the limitations of range and fuel consumption that plagued early Helldiver operations. Admiral Mark Mitcher, commanding Task Force 58, faced a difficult tactical decision. Japanese carrier forces under Admiral Jisaburo Ozawa had been located at extreme range from American carriers. Launching a strike would require aircraft to operate at the limits of their fuel capacity, with little margin for error or combat maneuvering. The strike force that launched that afternoon included 51 SB-2C Helldivers from various squadrons, along with 26 SBD Dauntless that remained in service with some units. The contrast between these aircraft types would become tragically apparent during the mission's recovery phase. Lieutenant Commander William Martin, leading the Helldivers from USS Essex, was acutely aware of the fuel consumption challenges facing his formation. The SB-2C, despite its larger size and more powerful engine, carried proportionally less fuel than the SBD it was designed to replace. This limitation had been identified during development but not adequately addressed due to weight and size constraints. The outbound flight proceeded normally, with American formations maintaining radio silence as they approached the Japanese fleet. Radar contact was established at maximum range, and the various aircraft types began their coordinated attacks on the enemy carriers. The Helldivers, tasked with suppressing anti-aircraft defenses, dove through heavy fire to deliver their ordnance accurately. Combat performance was satisfactory, with several bomb hits observed on Japanese carriers and cruisers. The Helldivers' precision diving capability proved valuable in the confused melee of carrier warfare, allowing pilots to select specific aim points rather than simply attempting area attacks. But fuel consumption during combat maneuvering had been severe. As American formations regrouped for the return flight, fuel gauges aboard the Helldivers showed critically low levels. Many pilots faced the choice between lightening their aircraft by jettisoning ammunition and equipment or attempting the return flight with insufficient fuel reserves. The return flight became a race against fuel consumption and approaching darkness. As the sun set over the Philippine Sea, American aircraft began arriving at their carriers in small groups and individuals rather than organized formations. Fuel gauges showed empty on many aircraft, forcing pilots to make immediate approaches regardless of deck conditions. Of the 51 Helldivers that had launched that morning, only 5 managed to land safely aboard their carriers. 46 aircraft were lost, with 32 running out of fuel and crashing or ditching in the ocean before reaching their ships. The remaining losses were attributed to combat damage or operational accidents during recovery. The contrast with SBD performance was stark and embarrassing. Of 26 Dauntless in the strike, only 2 were lost, 1 to enemy action and 1 in a landing accident. The older aircraft's superior fuel efficiency and reliability had proven decisive in the extended-range mission profile. Lieutenant Charles Downey of VB-80 was among the lucky 5 who made it back to their carriers. His fuel gauge showed empty as he entered the traffic pattern aboard USS Ticonderoga, and his engine quit on final approach. Only skillful flying and favorable wind conditions allowed him to reach the deck safely. "I thought that was it," Downey later recalled. "The engine just quit, and suddenly I was flying a very heavy glider toward a moving carrier deck. Somehow we made it, But I never forgot how close we came to joining those other guys in the water. The Philippine sea losses sparked immediate investigations into Helldiver fuel consumption and operational procedures. Modifications were implemented to improve fuel efficiency, and mission planning procedures were revised to account for the aircraft's limitations. But the lessons learned came at the cost of nearly 50 aircraft and their crews. Following Italy's surrender in September 1943, the country's military began a complex process of reorganization and cooperation with Allied forces. Part of this process involved Italian naval aviators observing and occasionally participating in Allied operations, providing unique perspectives on American naval aviation technology and tactics. Captain Romano Bernardi of the Regia Aeronautica had extensive experience with dive bombing techniques, having flown the Italian junkers Ju-87 Stuka during earlier phases of the Mediterranean War. When he was given the opportunity to observe American carrier operations in 1944, his professional assessment of the Helldiver provided valuable insights from a European perspective. The American approach to dive bombing represents a different philosophy from what we employed, Bernardi wrote in his official report to Italian naval headquarters. Where we emphasized simplicity and reliability, the Americans have chosen complexity and performance. The results are impressive when the systems function properly. Bernardi was particularly struck by the Helldiver's internal bomb bay, a feature absent from European dive bombers. This innovation eliminates much of the drag penalty associated with external ordnance, he noted. The tactical implications are significant higher cruise speeds, improved fuel efficiency, and reduced vulnerability to anti-aircraft fire during approach. However, the Italian observer also identified the system's weaknesses. The complexity of the hydraulic systems required for bomb bay operation creates multiple potential failure points, he continued. In combat conditions, this complexity may prove counterproductive if maintenance standards cannot be maintained. Sublieutenant Alessandro Vianello, a younger Italian pilot who flew training missions aboard American carriers, offered a different perspective. Having learned to fly on relatively simple Italian aircraft, he found the Helldiver's advanced systems both impressive and intimidating. Everything is automated or hydraulically assisted, Vianello wrote to his family. Landing gear, flaps, bomb bay doors, even the wing folding mechanisms. An Italian pilot accustomed to manual controls feels somewhat overwhelmed by the complexity. Yet the performance advantages are undeniable when everything functions correctly. The Italian assessments proved prescient regarding the Helldiver's operational characteristics. Their emphasis on the trade-offs between complexity and reliability would be borne out in combat experience throughout the Pacific War. Italian naval aviation had learned through bitter experience that sophisticated systems often failed under combat conditions, leaving pilots with unresponsive or partially functional aircraft. By early 1944, systematic improvements to both aircraft design and operational procedures began to pay dividends. The introduction of the SB-2C3 variant marked a crucial turning point in the Helldiver's combat career, addressing many of the fundamental problems that had plagued earlier models. The most significant improvement was the installation of the Wright R-2600-20 engine, producing 1,900 horsepower compared to 1,500 in earlier variants. This 33% increase in power transformed the aircraft's performance characteristics, particularly during the critical phases of carrier takeoff and landing. Equally important was the adoption of a 4-blade Curtiss electric propeller to replace the inadequate 3-blade unit used previously. The new propeller, featuring the same 12-foot diameter but with improved root cuffs, provided better thrust characteristics throughout the aircraft's speed range. Squadron VB-2 aboard USS Hornet was among the first to receive the improved SB-2C3 aircraft in March 1944. Squadron Commander Lieutenant Commander Robert Jackson immediately noticed the difference in performance. "It was like flying a completely different aircraft," he later reported. The power increase eliminated most of our takeoff weight restrictions, and handling qualities improved significantly. The new dive brakes represented another crucial innovation. Earlier Helldiver variants had suffered from severe buffeting during high-speed dives, limiting their effectiveness against heavily defended targets. The SB-2C3 introduced perforated dive brakes nicknamed cheese graters by maintenance crews that dramatically reduced buffeting while maintaining aerodynamic effectiveness. Aviation machinist mate First Class Tony Kowalowski, responsible for maintaining VB-2's aircraft, appreciated the mechanical improvements as much as the pilots. The hydraulic system was redesigned to be more reliable, he recalled. We still had problems, but they were manageable problems rather than complete system failures. Pilot confidence improved correspondingly. Lieutenant William Clenk, flying with VB-80, found that the improved aircraft characteristics allowed him to focus more attention on tactics and gunnery rather than simply keeping the aircraft under control. Once you learned to work with the beast rather than fighting it, you had a very capable weapon system, he observed. The statistical improvement was dramatic. Aircraft availability rates increased from less than 60% to over 80% as mechanical reliability improved. Mission completion rates similarly increased as pilots gained confidence in their aircraft's capabilities. Combat effectiveness data showed corresponding improvements. The SB-2C3 achieved higher percentages of bombs on target compared to earlier variants, reflecting both improved aircraft stability and pilot confidence. Anti-aircraft fire, while still dangerous, became less effective as pilots could concentrate on evasive maneuvering without worrying about aircraft control problems. October 24, 1944, marked the Helldivers' finest hour when squadrons from multiple carriers participated in the sinking of Musashi, one of Japan's 2 super battleships and the most heavily armored warship ever constructed. The battle in the sea beyond sea demonstrated both the effectiveness of coordinated carrier strikes and the precision bombing capability that made the Helldiver valuable despite its earlier problems. Admiral Takeo Kurida's center force, including the battleships Yamato and Musashi, had been detected by American submarines as it approached the Philippines. Task Force 38, under Admiral William Halsey, positioned its carriers to intercept the Japanese fleet as it transited the narrow waters between the Philippine Islands. The first radar contact came at 0820 hours from an SB-2C Helldiver flying from USS Intrepid, CV-11. Lieutenant Richard Shipman, piloting the reconnaissance aircraft, spotted the unmistakable silhouettes of Japanese battleships through broken cloud cover. His radio report triggered one of the largest coordinated airstrikes of the Pacific War. The attack developed throughout the morning and afternoon, with successive waves of aircraft from different carrier task groups striking the Japanese formation. The Helldivers' role was crucial. Their precision diving attacks were specifically targeted at the massive battleships, while torpedo planes concentrated on achieving underwater hits below the armor belt. Lieutenant Commander Ellis, leading the first strike from USS Lexington, observed the tactical challenge presented by the Japanese formation. Yamato and Musashi steamed together, their combined anti-aircraft fire creating an almost impenetrable defensive barrage. Coordinating dive bomber and torpedo attacks to divide this defensive fire required precise timing and excellent communication. We rolled in from the northeast, diving through the flak to get clean shots at Musashi's forward turrets, Ellis later reported. The ship was maneuvering violently, but her size made her an unmistakable target even through the anti-aircraft bursts. The accumulated damage from multiple strikes began to tell on Musashi by mid-afternoon. The great ship's list increased with each torpedo hit, and her speed decreased as flooding compromised engineering spaces. More importantly for the dive bombers, her anti-aircraft crews were being steadily attrited by the continuous attacks. By 1500 hours, Musashi had become separated from the main formation, making her an easier target for subsequent strikes. Air Group 20 from USS Enterprise found the battleship wallowing at reduced speed. Her anti-aircraft fire notably decreased from earlier engagements. Commander Daniel Smith, leading the Enterprise strike, directed his 14 F-6F fighters, 9 SB-2C Helldivers, and 8 TBF Avengers against the isolated battleship. The Helldivers, each carrying 2,000-pound bombs, achieved devastating accuracy against the now vulnerable target. For direct bomb hits and 4 torpedo strikes, Smith reported after the attack. The ship was clearly doomed. Though she continued to fight back with whatever guns remained operational, no Enterprise aircraft were lost in this attack, reflecting the degraded state of Musashi's defenses. The final blow came from Air Group 13 off USS Franklin, whose pilots found Musashi barely making headway and listing heavily to port. The Helldivers from Franklin achieved multiple hits on the ship's superstructure and remaining turrets, effectively silencing her anti-aircraft defense. By 1930 hours, the greatest battleship ever constructed slipped beneath the waters of the Sibuyan Sea, taking with her over 1,000 officers and men. The sinking represented a triumph of naval aviation over even the most heavily armored surface vessels, and the Helldivers' precision attacks had been crucial to this victory. The tactical lessons learned from the Musashi attack influenced subsequent operations throughout the Pacific. The coordination of dive bombers and torpedo planes, initially problematic, had been refined through experience. The Helldivers' ability to deliver heavy ordnance with precision against specific target points had proven decisive against heavily armored targets. While pilots received most of the attention in accounts of Pacific War aviation, the maintenance personnel who kept the Helldivers operational faced their own set of formidable challenges. The aircraft's complexity, which contributed to its capabilities, also created unprecedented maintenance requirements under combat conditions. Aviation Chief Machinist Mate Harold Chun, serving with VB-17 aboard USS Bunker Hill, supervised a maintenance team responsible for 18 SB-2C aircraft. With over 15 years of Navy experience, Chun had maintained everything from the simple aircraft of the 1920s to the latest wartime designs. None had challenged his skills like the Helldiver. Every system on that aircraft was interconnected, Chun later recalled. A hydraulic leak might affect the landing gear, bomb bay doors, flaps, and wing folding mechanisms simultaneously. Troubleshooting required understanding the entire aircraft, not just individual components. The hydraulic system posed particular challenges. Unlike simpler aircraft with manual controls, the Helldivers' advanced capabilities depended on hydraulic pressure for normal operation. System failures could render an aircraft completely unflyable, even if the engine and basic flight controls remained functional. Aviation machinist Mate Second Class Maria Rodriguez specialized in electrical systems, having received advanced training at the Navy's technical schools in Memphis, Tennessee. Her expertise became invaluable as Helldiver squadrons discovered that electrical failures were among the most common and difficult problems to diagnose. The wiring harnesses were incredibly complex, Rodriguez remembered. Hundreds of individual circuits running throughout the aircraft, all vulnerable to vibration, moisture, and combat damage. Finding a single broken wire or loose connection could take hours, even with proper test equipment. Combat damage assessment and repair presented unique challenges. Unlike earlier aircraft with relatively simple structures, Helldiver battle damage often affected multiple systems simultaneously. A single anti-aircraft hit might damage hydraulic lines, electrical circuits, and control cables, requiring extensive repairs before the aircraft could return to operational status. The availability of spare parts became a critical factor in maintaining squadron readiness. The Helldiver's complexity meant that each aircraft required a larger inventory of potential replacement parts compared to simpler designs. Supply chains, already strained by the vast distances of Pacific operations, struggled to keep pace with maintenance demands. Aviation storekeeper First Class James Washington managed spare parts inventory for an entire air group, responsible for ensuring that critical components were available when needed. His records show the scope of the challenge. Over 3,000 different part numbers for a single aircraft type, with usage rates varying dramatically depending on operating conditions. "We learned to prioritize," Washington recalled. Some parts failed predictably and could be ordered in advance. Others failed randomly, and we had to maintain larger safety stocks. The hydraulic pumps, electrical generators, and propeller controls were always in short supply. Improvisation became essential when standard parts were unavailable. Maintenance crews developed field modifications using available materials, created repair procedures not covered in official manuals, and learned to maintain aircraft under conditions never envisioned by the designers. The human cost of maintaining complex aircraft under combat conditions was reflected in accident and injury statistics. Maintenance personnel worked long hours in dangerous conditions, often with inadequate lighting and crude facilities. Heat exhaustion, injuries from aircraft systems, and accidents caused by fatigue were common problems. Despite these challenges, maintenance crews achieved remarkable aircraft availability rates. By late 1944, most Helldiver squadrons maintained over 80% of their aircraft in operational status, a figure that compared favorably with simpler aircraft designs operating under less demanding conditions. The Helldivers' combat career extended well beyond World War II, with French naval aviation operating the aircraft in Indochina from 1951 to 1954. This service provided unique insights into the aircraft's capabilities in a different type of conflict counterinsurgency operations against the Viet Minh. In 1949, the French Navy selected surplus SB-2C 5 Helldivers to replace worn-out SBD Dauntless aircraft that had served since World War II. 2 squadrons were equipped with the aircraft, Flotille 3F and Flotille 16F, both frontline carrier squadrons based aboard the aircraft carrier Airmanches. Lieutenant Commander Pierre Mesmer, commanding Flotille 3F, brought extensive experience with carrier aviation to his evaluation of the Helldiver. Having flown British and American aircraft during World War II, Mesmer was well positioned to assess the aircraft's strengths and limitations in combat conditions. The Helldiver represented a significant improvement over the Dauntless in terms of payload and performance, Mesmer wrote in his squadron reports. However, it also represented a substantial increase in complexity and maintenance requirements. For operations from aircraft carriers in tropical conditions, this complexity proved challenging. The Gulf of Tonkin's climate posed severe challenges for complex aircraft systems. High temperatures, humidity, and salt spray accelerated corrosion and system failures. The Helldiver's extensive hydraulic and electrical systems proved particularly vulnerable to these environmental stresses. Pilot Lieutenant Jean-Claude Rudel flew over 60 combat missions in Helldivers during the siege of Dien Bien Phu. His perspective on the aircraft's combat effectiveness in counterinsurgency operations provided valuable insights into tactical employment under these conditions. Against dispersed ground targets in jungle terrain, the Helldiver's precision diving capability proved invaluable, Rudel recalled. We could deliver ordnance accurately within 50 meters of friendly positions, something impossible with level bombing techniques. This precision was crucial when supporting ground forces in close contact with the enemy. The aircraft's internal bomb bay design offered advantages for the types of ordnance required in Indochina. Fragmentation bombs, napalm canisters, and other specialized weapons could be carried internally, reducing drag and improving fuel efficiency for the extended-range missions often required in the theater. However, maintenance challenges were severe. Aviation mechanic André Dubois, serving with the maintenance section aboard Airmanches, described the difficulties of maintaining complex aircraft under operational conditions far from industrial support facilities. We learned to cannibalize aircraft to keep others operational, Dubois remembered. Spare parts supply from France was unreliable, and the tropical climate accelerated wear on every component. Sometimes only half our aircraft were operational at any given time. The tactical employment of Helldivers in Indochina evolved to emphasize low-level attack missions rather than the traditional high-altitude dive bombing for which the aircraft was designed. These missions, sometimes conducted at altitudes of only a few hundred feet, maximized the aircraft's precision while minimizing exposure to anti-aircraft fire. The French experience highlighted both the advantages and limitations of complex aircraft systems in sustained combat operations. While the Helldivers' capabilities were impressive when fully operational, maintaining those capabilities under austere conditions required resources and expertise that were often unavailable. French Helldiver operations in Indochina concluded in 1954 with the fall of Dien Bien Phu and the subsequent Geneva Accords. The aircraft had served with distinction in a conflict very different from the carrier battles of World War II, demonstrating the versatility of the basic design while also revealing the challenges of operating complex systems under demanding conditions. April 7, 1945, witnessed the climactic destruction of the Imperial Japanese Navy's last operational battleship, Yamato, in what would become the Helldivers' most celebrated victory. The coordinated attack that sent the world's largest battleship to the bottom of the East China Sea represented the perfection of carrier aviation tactics developed throughout the Pacific War. Operation Tengo, Japan's desperate attempt to use Yamato as a giant kamikaze weapon against American forces at Okinawa, began with the battleship's departure from the inland sea on April 6, The enormous warship, accompanied by the cruiser Yahagi and 8 destroyers, steamed southwest on what was intended as a one-way mission to disrupt American amphibious operations. American submarines USS Threadfin and USS Hackleback detected the Japanese force as it cleared the inland sea, transmitting contact reports that reached Task Force 58 within hours. Admiral Mark Mitcher, commanding the fast carriers, immediately began planning the largest single-target airstrike of the Pacific War. The morning of April 7th dawned clear and calm, perfect conditions for carrier operations. By 1,000 hours, over 200 aircraft from task groups 581 and 583 were airborne and heading northwest toward the Japanese force. The strike included helldivers from USS Yorktown, USS Intrepid, USS Langley, and USS Independence. Lieutenant Commander Herbert Houck, leading VB-9 from USS Yorktown, carried 2,000-pound bombs specifically selected for attacking heavily armored targets. Intelligence estimates suggested that Yamato's deck armor could withstand anything less than direct hits from the heaviest ordnance available. "We knew this was the big one," Houck later recalled. "Everything we'd learned about attacking heavily defended ships would be put to the test against the most powerful warship ever built. There was no room for error. This was our chance to finish off the Japanese battle line once and for all." The first American aircraft reached the Japanese force at 1,232 hours, finding Yamato steaming at 22 knots in the center of a defensive formation. The battleship's anti-aircraft armament was formidable: 24 5-inch dual-purpose guns, 150 25mm automatic weapons, and 4 13mm machine guns. The coordinated attack that followed represented the culmination of 3 years of tactical development. Torpedo planes approached from multiple directions to divide the defensive fire, while dive bombers attacked from high altitude to penetrate the ship's heavily armored deck. Fighter aircraft suppressed anti-aircraft positions and engaged any Japanese fighters that attempted to interfere. Lieutenant Commander James Ramage, leading VB-10 from USS Intrepid, achieved one of the first bomb hits on Yamato's forward superstructure. The ship was maneuvering violently, but her size made accurate bombing possible even through heavy defensive fire, he reported. "You couldn't miss something that big if you pressed the attack home." The accumulated damage from multiple waves began to tell on the giant battleship by 1,300 hours. Torpedo hits had caused flooding that reduced her speed and increased her list to port. More critically, bomb hits had damaged several anti-aircraft gun positions, creating gaps in the defensive fire pattern. Aviation radioman Second Class Robert Campbell, flying as rear gunner in a helldiver from USS Langley, witnessed the climactic phase of the attack. "The ship was listing heavily and smoking from multiple hits," he recalled. "But she was still fighting back with everything she had. Those 25mm guns were putting up a wall of fire." The final phase of the attack concentrated on Yamato's port side, where previous torpedo hits had caused the most damage. Helldivers from USS Independence achieved multiple hits with 1,000-pound bombs, while additional torpedo attacks increased the flooding beyond the ship's ability to compensate. At 1,405 hours, Yamato's forward magazine exploded in a massive fireball visible from over 100 miles away. The explosion, caused by the detonation of over 1,000 tons of ammunition, broke the ship's back and sent her to the bottom within minutes. Of her crew of over 3,000 men, fewer than 300 survived. The destruction of Yamato marked the effective end of the Imperial Japanese Navy as an organized fighting force. More importantly for naval aviation history, it demonstrated the complete obsolescence of the battleship as the primary instrument of naval power. Carrier-based aircraft had proven capable of destroying even the most heavily protected surface vessels. For the helldiver, Yamato's destruction represented vindication of the aircraft's capabilities and the long development process that had brought it to operational effectiveness. The precision attacks that penetrated the battleship's armor had been achieved by an aircraft that many had considered unsuitable for combat operations just 2 years earlier. The helldiver's final combat service occurred in an unexpected theater, the mountains and islands of Greece, during the civil war that raged from 1946 to 1949. This conflict provided unique insights into the aircraft's effectiveness in counterinsurgency operations against irregular forces. In mid-1949, The United States delivered 48 surplus SB-2C, 5 Helldivers to the Royal Hellenic Air Force aboard the aircraft carrier USS Sicily, CVE 118. The transfer represented part of American efforts to support the Greek government against communist insurgents who had been waging guerrilla warfare since the end of World War II. The aircraft were immediately assigned to the 336th Squadron at Larissa Air Base, replacing war-weary Supermarine Spitfires that had been pressed into ground attack roles. Squadron leader Demetrius Kontaxis, commanding the unit, faced the challenge of transitioning his pilots from single-seat fighters to complex twin-seat dive bombers. The Helldiver was unlike anything we had operated previously, Kontaxis recalled in his post-war memoirs. The aircraft systems were far more complex than the Spitfire, requiring extensive retraining for both pilots and maintenance personnel. However, the payload and precision capabilities were immediately apparent. The Greeks made several modifications to their Helldivers to suit the specific requirements of counterinsurgency operations. Since communist forces possessed no fighter aircraft, the rear-facing twin machine guns were removed and the gunner's position was often left empty to save weight. Additional fuel tanks were sometimes carried to extend range for operations in remote mountainous areas. Greek pilots called the aircraft Terras, beast, echoing the American nickname while adding their own cultural interpretation. The name reflected both respect for the aircraft's capabilities and frustration with its complexity and maintenance requirements. Flight Lieutenant Yannis Palaiologos flew over 80 combat missions against communist positions in northern Greece. His combat diary provides detailed insights into the tactical employment of Helldivers in mountainous terrain against dispersed, well-camouflaged targets. The precision possible with diving attacks proved invaluable against targets in rough terrain, Palaiologos wrote. Communist positions were often located in caves or ravines where level bombing would be ineffective. The steep diving angles possible with the Helldiver allowed us to place ordnance accurately even in the most challenging terrain. The internal bomb bay design proved advantageous for carrying the specialized ordnance required for counterinsurgency operations. Fragmentation bombs were particularly effective against personnel targets, while napalm proved useful for destroying supply depots and denying terrain to guerrilla forces. Maintenance challenges were severe, however. The Royal Hellenic Air Force lacked the sophisticated support infrastructure required for complex aircraft systems. Chief Mechanic Stavros Antonopoulos described the difficulties of maintaining hydraulic and electrical systems with limited spare parts and technical support. We learned to improvise constantly, Antonopoulos recalled. American technical manuals were often unavailable in Greek translation, and spare parts supply was unreliable. We cannibalized aircraft to keep others operational, and developed field modifications that were never in any official manual. Despite these challenges, Greek Helldivers achieved remarkable success in their counterinsurgency role. The aircraft's precision attack capability proved decisive in several key engagements, particularly the clearing of communist strongholds in the Gramozvitsi mountain range during the final phases of the Civil War. The psychological impact of the Helldivers' precision attacks was as important as the physical damage inflicted. Communist forces, accustomed to inaccurate level bombing attacks, found themselves vulnerable to precisely delivered ordnance that could strike even well-protected positions. By 1952, as the Civil War wound down, most Greek Helldivers were showing severe wear from intensive operations under austere conditions. The transition to F-84 Thunderjets in 1953 marked the end of the aircraft's frontline service with the Royal Hellenic Air Force, though some continued in secondary roles until 1957. The Greek experience demonstrated both the potential and limitations of complex aircraft systems in counterinsurgency operations. While the Helldivers' capabilities were impressive when properly maintained, sustaining those capabilities under resource-constrained conditions required constant innovation and dedication from maintenance personnel. The development of the Helldiver through its various models reflected the continuous process of improvement that characterized American wartime aircraft production. Each variant incorporated lessons learned from operational experience, though some problems proved inherent to the basic design and could never be completely eliminated. The original SB-2C-1 represented the initial production configuration, incorporating the 800 modifications demanded by the Navy before acceptance. Despite these changes, only 200 SB-2C-1 aircraft were built before production shifted to the improved SB-2C-1C variant. The early aircraft were retained for training purposes, their various problems making them unsuitable for combat operations. Chief Test Pilot Howard Hughes, on temporary assignment to Curtiss-Wright, provided detailed assessments of the SB-2C-1's characteristics during development testing. His reports, preserved in company archives, offer insights into the specific problems that plagued early variants. Lateral stability is marginal under all conditions and becomes dangerous at approach speeds. Hughes wrote in one report, "The aircraft exhibits severe buffeting in steep dives, limiting its effectiveness in the primary mission profile. Hydraulic system reliability is unacceptable for carrier operations." The SB-2C-1C addressed some of these problems through the introduction of 20mm cannons replacing the original 50 caliber machine guns in the wings. This change reflected combat experience, suggesting that the heavier armament was more effective against both air and ground targets. 778 SB-2C-1C aircraft were produced, becoming the first variant to see extensive combat service. Squadron commanders provided feedback that drove further improvements in the SB-2C-3, which became available in spring 1944. The most significant change was the introduction of the Wright R-2600-20 engine producing 1900 horsepower, a 33% increase over earlier variants. Lieutenant Commander Robert Jackson, commanding VB-2 aboard USS Hornet, documented the performance improvements achieved with the SB-2C-3. "Takeoff performance improved dramatically," he reported. "We could operate at maximum gross weight from carrier decks without the power limitations that had restricted earlier variants." The four-blade Curtiss electric propeller introduced with the SB-2C-3 represented another crucial improvement. The new propeller, featuring improved root cuffs and better blade design, provided superior thrust characteristics throughout the aircraft's operating envelope. This change addressed one of the fundamental power transmission limitations that had hampered earlier variants. Perforated dive brakes, nicknamed cheese graters by maintenance personnel, eliminated the severe buffeting that had limited dive bombing effectiveness in earlier models. The new brakes maintained aerodynamic effectiveness while allowing smoother airflow during high-speed descents. Chief Aviation Machinist Mate Thomas Chun, responsible for maintaining dive brake systems, appreciated the mechanical simplicity of the perforated design. "The original solid brakes created tremendous turbulence behind the aircraft," he recalled. "The perforated design smoothed out the airflow while actually improving control response during diving attacks." The SB-2C-4, entering service in late 1944, incorporated numerous detail improvements based on combat experience. The most visible change was the introduction of cheese grater wing flaps perforated surfaces that improved stability without increasing drag. 2,045 SB-2C-4 aircraft were produced, making it the most numerous variant. Advanced avionics systems were another SB-2C-4 improvement. The APS-4 radar system, mounted in a distinctive pod beneath the starboard wing, provided surface search capability that proved valuable for anti-shipping missions and navigation in poor weather conditions. The final production variant, the SB-2C-5, appeared in February 1945 but arrived too late to see extensive World War II service. Improvements included increased fuel capacity, a frameless pilot's canopy for better visibility, and numerous detail refinements based on operational experience. 970 SB-2C-5 aircraft were completed before production ended in October 1945. Canadian production contributed significantly to overall Helldiver numbers, with Fairchild Aircraft Limited producing 300 aircraft, designated SBF, and Canadian Car and Foundry building 894, designated SBW. These aircraft were essentially identical to their American-built counterparts, though some incorporated minor modifications requested by the Royal Canadian Air Force. The land-based A-25A Shrike variant, intended for the U.S. Army Air Forces, eliminated carrier-specific equipment such as arresting hooks and wing-folding mechanisms. Larger main wheels and other detail changes distinguished the variant, though Army interest in dive bombers had waned by the time deliveries began in late 1943. Total production of all variants reached 7,140 aircraft, making the Helldiver one of the most numerous American aircraft types of World War II. This production achievement was remarkable considering the program's troubled development and the complex manufacturing challenges that had to be overcome. Behind every successful Helldiver mission lay countless hours of maintenance work by dedicated ground crews who fought their own war against the aircraft's complex systems. The maintenance burden associated with the Helldiver was unprecedented in naval aviation, requiring new approaches to training, supply, and organization. Aviation Chief Machinist Mate Samuel Rodriguez commanded the maintenance section for Air Group 11 aboard USS Hornet during 1944 and 45. With 22 years of Navy experience, Rodriguez had maintained aircraft ranging from the simple biplanes of the 1920s to the most advanced wartime designs. None had challenged his skills like the Helldiver. Every system on that airplane was connected to every other system, Rodriguez later recalled. A hydraulic leak could ground the aircraft completely, even if the engine was perfect. We had to understand the entire airplane, not just our individual specialties. The hydraulic system posed the greatest maintenance challenge. Unlike earlier aircraft with simple, manually operated controls, the Helldiver depended on hydraulic power for landing gear operation, wing folding, bomb bay doors, and flight control assistance. System failures could render an otherwise airworthy aircraft completely inoperable. Aviation machinist Mate First Class Catherine Wong specialized in hydraulic systems, having received advanced training at the Navy's technical schools in Norman, Oklahoma. Her expertise became invaluable as squadrons discovered that hydraulic problems were among the most common and time-consuming failures to address. The system operated at very high pressures to achieve the performance required, Wong remembered. This meant that even small leaks could cause complete system failures. Finding and fixing those leaks often required disassembling major portions of the aircraft structure. Electrical system maintenance presented equally complex challenges. The Helldiver's advanced avionics, lighting systems, and engine controls required reliable electrical power under all operating conditions. Salt spray, vibration, and temperature extremes in carrier environments accelerated electrical system degradation. Aviation electrician Mate Second Class James Patterson maintained electrical systems for VB-6 throughout the squadron's Pacific deployment. His maintenance logs document the scope of electrical problems encountered and the innovative solutions developed by maintenance personnel. We learned to waterproof connections using whatever materials were available, Patterson recalled. Official procedures called for specific compounds and techniques that weren't always practical under shipboard conditions. We used everything from petroleum jelly to adhesive tape to keep moisture out of critical circuits. Combat damage assessment and repair added another layer of complexity to maintenance operations. Battle damage often affected multiple systems simultaneously, requiring comprehensive analysis to determine repair priorities and procedures. A single anti-aircraft hit might damage hydraulic lines, electrical circuits, control cables, and structural components. Aviation structural mechanic First Class Robert Kim specialized in combat damage repair, developing techniques for restoring aircraft to operational status under field conditions. His innovations were eventually incorporated into official maintenance procedures and training programs. We learned to look at the whole aircraft when assessing battle damage, Kim explained. What looked like minor damage might have affected systems throughout the airplane. We had to test everything before releasing an aircraft back to flight operations. Spare parts supply represented a constant challenge for maintenance operations. The Helldiver's complexity meant that each aircraft required over 3,000 different part numbers, with usage rates varying dramatically based on operating conditions and mission profiles. Aviation storekeeper Chief Petty Officer Maria Santos managed spare parts inventory for an entire air group, responsible for forecasting requirements and maintaining adequate stock levels under constantly changing conditions. Her records provide insights into the logistical challenges of supporting complex aircraft in remote theaters. We learned to predict failure patterns and adjust our inventory accordingly, Santos recalled. Some parts failed predictably based on flight hours or calendar time. Others failed randomly, forcing us to maintain larger safety stocks. The hydraulic pumps, propeller governors, and radio equipment were always in short supply, Improvisation became essential when standard parts or procedures were unavailable. Maintenance crews developed field modifications using available materials, created repair procedures not covered in official manuals, and learned to maintain aircraft under conditions never envisioned by the original designers. The human cost of maintaining complex aircraft under combat conditions was reflected in casualty and injury statistics. Maintenance personnel worked long hours in dangerous conditions, often with inadequate lighting and primitive facilities. Heat exhaustion, injuries from aircraft systems, and accidents caused by fatigue were common problems that affected maintenance effectiveness. Despite these challenges, maintenance crews achieved remarkable aircraft availability rates that compared favorably with simpler aircraft designs. By late 1944, most Helldiver squadrons maintained over 80% of their aircraft in operational status, a testament to the skill and dedication of maintenance personnel. Training programs evolved to address the unique challenges of Helldiver maintenance. Specialized schools were established to teach the complex systems, and mobile training teams deployed to forward areas to provide on-site instruction. These programs represented a significant investment in human resources but proved essential for maintaining operational effectiveness. As World War II ended in August 1945, military aviation experts began comprehensive evaluations of the aircraft that had fought the war. The Helldivers assessment revealed a complex picture of an aircraft that had overcome severe development problems to achieve significant combat success, while also highlighting the challenges of developing complex systems under wartime pressures. Rear Admiral Apollo Sowsek, commanding Naval Air Test Center at Patuxent River, Maryland, supervised extensive post-war testing of all major Navy aircraft types. His final report on the SB-2C program, completed in 1947, provided authoritative assessments of the aircraft's strengths and limitations. The SB-2C Helldiver represents both the potential and the pitfalls of advanced aircraft design, Sowsek wrote. When functioning properly, the aircraft demonstrated capabilities that exceeded those of any previous dive bomber. However, the complexity required to achieve those capabilities created maintenance and reliability challenges that affected operational effectiveness. Statistical analysis of combat operations provided objective measures of the Helldiver's effectiveness. Despite its troubled development, the aircraft had been responsible for sinking more enemy ship tonnage than any other Allied dive bomber. This achievement reflected both the large numbers of aircraft deployed and their precision attack capability. Captain Frederick Sherman, who had commanded carriers throughout the Pacific War, offered a fleet commander's perspective on the Helldiver's contribution to victory. The aircraft's precision attack capability was decisive in many engagements, he observed. However, the maintenance burden and reliability problems affected our operational flexibility. Simpler aircraft might have been more effective overall. The comparison with the Douglas SBD Dauntless remained controversial throughout the post-war period. While the Helldiver was faster, carried more ordnance, and possessed greater diving capability, the older aircraft was more reliable, easier to maintain, and had longer range. Many pilots who flew both aircraft continued to prefer the Dauntless despite its limitations. Lieutenant Colonel Marion Carl, the Marine Corps ace who had flown both aircraft types, provided a pilot's perspective on their relative merits. The SBD was like an old friend, reliable, forgiving, and predictable, he recalled. The SB-2C was more like a thoroughbred racehorse capable of outstanding performance, but requiring constant attention and expert handling. International assessments of the Helldiver varied based on the specific requirements and experience of different air forces. The French Navy's experience in Indochina suggested that the aircraft was well suited to precision attack missions but required extensive logistical support. The Greek experience in Civil War operations demonstrated effectiveness against irregular forces but also highlighted maintenance challenges. British evaluations remain negative, with Royal Navy analysts concluding that the aircraft's handling characteristics made it unsuitable for carrier operations under Royal Navy procedures. However, these assessments reflected different operational philosophies and training standards rather than fundamental aircraft deficiencies. The technological legacy of the Helldiver influenced subsequent aircraft development in several important ways. The emphasis on internal weapons carriage, hydraulically operated systems, and precision attack capability became standard features in later designs. The lessons learned about complexity versus reliability influenced the development of simpler, more robust aircraft for specific mission roles. Douglas Aircraft Company's AD Skyraider, which replaced the Helldiver in Navy service, represented a conscious return to simpler, more reliable design philosophy while incorporating the precision attack lessons learned from Helldiver operations. The Skyraider's success validated the approach of emphasizing reliability over advanced systems in tactical aircraft. The Helldiver's combat record included participation in every major Pacific War engagement from late 1943 through the end of hostilities. Approximately 30 Navy squadrons operated the aircraft aboard 13 different carriers, achieving a combat record that included the destruction of numerous Japanese warships and thousands of ground targets. Aircraft losses to all causes totaled approximately 1,500 Helldivers during combat operations, a loss rate comparable to other single-engine combat aircraft of the period. However, the complexity of the aircraft meant that maintenance-related accidents and incidents occurred at higher rates than with simpler designs. Post-war surplus aircraft found employment with numerous international air forces, providing valuable service in conflicts ranging from the Greek Civil War to the French operations in Indochina. These extended service careers demonstrated the basic soundness of the aircraft design, while also revealing the ongoing challenges of maintaining complex systems under austere conditions. The final assessment of the Helldiver program must acknowledge both its achievements and its shortcomings. The aircraft overcame severe development problems to become an effective combat weapon that contributed significantly to Allied victory in the Pacific. However, the time, resources, and effort required to achieve that effectiveness raised questions about the wisdom of pursuing overly complex solutions to military requirements. The men and women who built the Helldiver at the Columbus plant represented a cross-section of American society during World War II. Their experiences reflected the broader social and economic changes occurring throughout the country, while their dedication and innovation were crucial to the aircraft's eventual success. Margaret Thompson, a welder from rural Ohio who joined the Columbus workforce in early 1942, represented thousands of women who entered industrial jobs during the war. At age 23, she had never worked outside her family's farm before the war created opportunities in defense production. "We knew we were building something important," Thompson recalled in a post-war interview. "Every rivet, every weld, every wire connection might make the difference between life and death for some pilot over the Pacific. That knowledge kept us going through 12-hour shifts and constant production pressure." The workforce at Columbus reflected America's increasing diversity as the war progressed. African American workers, previously excluded from many industrial jobs, found opportunities in defense plants that had been denied in peacetime. Thomas Jefferson, who had migrated from Mississippi to find defense work, became a supervisor in the hydraulic systems assembly section. The work was hard and the hours were long, but it was steady employment with decent wages, Jefferson remembered. More importantly, we were contributing to something larger than ourselves. That factory was helping to win the war, and we were all part of that effort. Mexican-American workers also found opportunities in the defense plants. Carlos Martinez had worked in agriculture before the war but learned precision assembly techniques that would serve him throughout his post-war career. His attention to detail made him valuable in the complex electrical systems assembly section. "Every connection had to be perfect," Martinez recalled. "A loose wire or poor solder joint could cause system failures that might cost lives. We took pride in our work because we knew it mattered." The integration of these diverse workers wasn't always smooth. Racial tensions, cultural differences, and competition for jobs created conflicts that sometimes affected production. However, the shared purpose of supporting the war effort gradually overcame many of these divisions. Helen Chong, one of the few women in supervisory positions, worked to create teams that could function effectively despite social barriers. Her approach emphasized competence and dedication rather than background or demographics, helping to establish standards that would influence post-war industrial practices. "We learned that good work was good work, regardless of who did it," Chong observed. "The aircraft didn't care about the race or gender of the person who installed a component. What mattered was whether the job was done correctly." The technical skills developed at Columbus would serve workers throughout their post-war careers. Many who learned precision manufacturing techniques during the war became supervisors and skilled tradespeople in civilian industries. The training programs established for Helldiver production became models for post-war technical education. Veterans returning from military service often joined the Columbus workforce, bringing combat experience that helped bridge the gap between factory and battlefield. These workers understood the importance of quality control from a different perspective, having seen the consequences of equipment failures in combat conditions. Sergeant Robert Kim, who had served with a Marine fighter squadron before returning to work at Columbus, brought valuable insights about aircraft reliability requirements. His understanding of combat conditions influenced quality control procedures and helped identify potential problems before aircraft left the factory. "We knew what happened when aircraft systems failed in combat," Kim explained. "That knowledge made us more careful about every detail of production. A shortcut that saved a few minutes in the factory could cost lives over the Pacific." The social impact of defense production extended far beyond the factory gates. The Columbus plant employed over 20,000 workers at its peak, making it one of the largest employers in central Ohio. Wages from defense work supported families throughout the region and contributed to economic development that continued long after the war ended. Housing, transportation, childcare, and other social services had to expand rapidly to support the growing workforce. These infrastructure improvements benefited the entire community and established foundations for post-war growth and development. The end of Helldiver production in October 1945 marked the beginning of difficult transitions for both workers and community. Defense contracts ended abruptly, leaving many workers unemployed and uncertain about their future. However, the skills and experience gained during the war years provided foundations for new careers and opportunities. Many Columbus workers eventually found employment in the growing civilian aviation industry, automotive production, and other manufacturing sectors that expanded during the post-war economic boom. The technical skills, work discipline, and teamwork abilities developed during wartime production proved valuable in peacetime careers. The legacy of the Columbus workers extended beyond their individual contributions to include innovations in manufacturing techniques, quality control procedures, and workforce management that influenced American industrial development for decades after the war ended. As the last Helldiver rolled off the Columbus production line in October 1945, the complete story of the aircraft's development and combat career could finally be assessed. The statistics were impressive by any measure, but they told only part of the story of what had been achieved against overwhelming odds. Total production reached 7,140 aircraft of all variants, making the Helldiver one of the most numerous American aircraft of World War II. This figure included 5,516 aircraft built at Columbus, with the remainder produced at Canadian facilities or by other contractors. The financial investment in the Helldiver program was enormous. The Navy had spent $27 million constructing the Columbus factory, plus $98 million additional for production contracts. Total program costs, including development, testing, and production support, exceeded $200 million, equivalent to over $3 billion in contemporary purchasing power. The human cost was significant as well. Over 100 test pilots, factory workers, and production personnel had died during the development and manufacturing phases. Combat losses totaled approximately 1,500 aircraft and 3,000 aircrew members, though this figure included losses to all causes rather than just enemy action. Combat effectiveness statistics painted a picture of ultimate success despite early problems. Helldiver squadrons had been responsible for sinking more enemy ship tonnage than any other Allied dive bomber type. The list of major Japanese warships sunk or damaged by Helldiver attacks included the super battleships Musashi and Yamato, multiple aircraft carriers, and dozens of cruisers and destroyers. Captain David Campbell, who had commanded Air Group 11 during major Pacific operations, provided a fleet commander's assessment of the aircraft's contribution. The Helldiver's precision attack capability was decisive in many engagements, he observed. When the aircraft and crews functioned properly, the results were spectacular. The challenge was achieving that level of performance consistently. Maintenance statistics revealed the ongoing challenges of operating complex aircraft under combat conditions. Helldiver squadrons required approximately 30% more maintenance man-hours per flight hour compared to simpler aircraft types. This increased maintenance burden affected operational flexibility and required larger support organizations. However, by war's end, most of these problems had been resolved through improved procedures and better training. Aircraft availability rates in late 1945 averaged over 85%, comparable to much simpler aircraft designs operating under similar conditions. The international assessment of the Helldiver varied considerably based on different operational requirements and support capabilities. Countries with advanced industrial bases and extensive technical support found the aircraft effective for specialized missions. Those with limited support infrastructure struggled with the complexity and maintenance requirements. Post-war service with various air forces extended the aircraft's operational life well into the 1950s. French operations in Indochina demonstrated the aircraft's effectiveness in counterinsurgency roles, while Greek service during the Civil War showed its precision attack capability against irregular forces. The technological legacy of the Helldiver influenced aircraft development for decades after World War II. The emphasis on internal weapons carriage, precision attack systems, and advanced avionics became standard features in subsequent designs. However, the lessons learned about complexity versus reliability also influenced design philosophies toward simpler, more robust solutions. The Douglas AD Skyraider, which replaced the Helldiver in Navy service, represented a conscious return to simpler design principles while incorporating the precision attack lessons learned from Helldiver operations. The Skyraider's remarkable success and longevity validated this approach to tactical aircraft design. Training programs developed for Helldiver operations established precedents for managing complex aircraft systems that influenced military aviation training for generations. The specialized schools, maintenance procedures, and operational techniques developed for the aircraft became models for subsequent programs. The industrial impact of Helldiver production contributed to American manufacturing capabilities that extended far beyond aviation. The precision manufacturing techniques, quality control procedures, and workforce management innovations developed at Columbus influenced post-war industrial development throughout the Midwest. The ultimate measure of any military aircraft lies not in statistics or technical specifications, but in the experiences of the men who flew it in combat. The voices of Helldiver pilots and crew members provide the most authentic assessment of the aircraft's strengths, limitations, and overall effectiveness in the crucible of aerial warfare. Captain William Clenk, who flew over 60 combat missions in SB-2C aircraft with VB-80, offered a perspective shaped by extensive operational experience. The Helldiver demanded respect, he recalled during a post-war interview. It wasn't a forgiving aircraft like the Dauntless, but once you learned to work with it rather than against it, you had a very capable weapon. Clenk's experience included missions against heavily defended Japanese positions, anti-shipping strikes, and close air support operations. His logbook documented the evolution of his relationship with the aircraft from initial skepticism to grudging respect and eventually to appreciation for its capabilities. The precision possible with diving attacks was remarkable, Clenk continued. We could put bombs exactly where they needed to go, even in challenging weather conditions or against heavily defended targets. That precision often made the difference between mission success and failure. Lieutenant Commander Robert Jackson, who commanded VB-2 aboard USS Hornet during the Philippines campaign, emphasized the importance of training and experience in maximizing the aircraft's potential. The Helldiver was like a high-performance race car, he observed. In the hands of a skilled pilot, it could do things that seemed impossible. But it required constant attention and expert handling. Jackson's squadron achieved some of the highest accuracy rates recorded for dive bombing attacks, reflecting both improved aircraft capabilities and refined tactics developed through experience. His pilots spent countless hours practicing precision attacks against various target types, developing techniques that maximize the Helldiver's strengths while minimizing its limitations. Aviation radioman Second Class James Patterson provided the perspective of rear-seat crew members who operated the aircraft's defensive armament and navigation equipment. The Helldiver gave us capabilities we'd never had before, Patterson recalled. The improved visibility from the rear cockpit, the more powerful defensive guns, and the advanced radio equipment made us much more effective than in earlier aircraft. Patterson flew over 40 combat missions as a rear gunner, experiencing everything from fighter attacks to anti-aircraft fire. His survival depended not just on pilot skill but also on the aircraft's ability to absorb battle damage and continue flying, a capability that proved decisive in numerous engagements. "I saw Helldivers come back with damage that would have destroyed other aircraft," Patterson remembered. The rugged construction and redundant systems often meant the difference between getting home safely and becoming another casualty statistic. Lieutenant Charles Downey provided a unique perspective, having flown both the SBD Dauntless and the SB-2C Helldiver during his Pacific War service. His comparative assessment was based on direct experience with both aircraft types under similar combat conditions. The Dauntless was like an old friend, reliable, predictable, and forgiving of mistakes, Downey observed. The Helldiver was more like a thoroughbred horse capable of extraordinary performance, but requiring expert handling and constant attention. Both aircraft had their place in the war effort. Downey's experience included the disastrous Philippine Sea mission, where fuel consumption problems led to massive aircraft losses. However, he also participated in successful strikes against Japanese shipping and ground targets where the Helldiver's precision proved decisive. Commander Harold Hayes, who had served as both pilot and squadron leader during Helldiver operations, offered insights into the command perspective on aircraft effectiveness. "The maintenance burden was always a consideration in mission planning," he noted. "We had to account for aircraft that might be unavailable due to system problems or required maintenance." Despite these challenges, Hayes emphasized the aircraft's combat effectiveness when properly maintained and operated. "When everything worked correctly, the Helldiver was the finest dive bomber in the world," he stated. The challenge was achieving that level of performance consistently under combat conditions. Aviation machinist mate First Class Michael Chun provided the maintenance perspective that was crucial to operational success. "Every Helldiver was like a complex puzzle," he recalled. "Understanding how all the systems worked together was essential for keeping the aircraft operational." Chen's expertise with hydraulic and electrical systems made him invaluable to squadron operations. His innovations in troubleshooting and repair procedures were eventually incorporated into official maintenance manuals and training programs. The collective voice of these combat veterans painted a complex picture of an aircraft that demanded the best from its crews but rewarded skillful operation with capabilities unmatched by simpler designs. Their testimonies provided the human dimension essential to understanding the Helldiver's true significance in aviation history. On September 13, 1949, the last operational Helldiver in United States Navy service lifted off from the deck of USS Valley Forge, CV-45, for what would prove to be the type's final combat mission. The pilot was Lieutenant Commander David Morrison of VA-54, a veteran who had flown SB-2C aircraft since their combat debut 6 years earlier. Morrison's mission was routine, a training exercise off the California coast designed to maintain pilot proficiency and test newly installed equipment. As he climbed away from the carrier's deck, Morrison reflected on the long journey that had brought him and his aircraft to this moment in history. "It seemed fitting that the last flight would be a training mission," Morrison later recalled. The Helldiver had always been a demanding instructor, teaching hard lessons about precision, discipline, and attention to detail. Those lessons had served us well in combat and would continue to serve naval aviation in the future. The aircraft Morrison flew that day was an SB-2C-5, incorporating all the improvements and refinements developed during the aircraft's lengthy evolution. The contrast with the early variants he had flown in combat was remarkable: improved reliability, better handling characteristics, and systems that functioned as originally intended. As Morrison completed his training profile and returned to Valley Forge, he was participating in a transition that would define the future of naval aviation. The Douglas AD Skyraider, already entering fleet service, represented a different approach to attack aircraft design: simpler systems, greater reliability, and improved versatility for diverse mission profiles. The Helldiver's legacy would extend far beyond its operational service life. The lessons learned during its troubled development and eventual success would influence aircraft design and production for decades to come. The emphasis on thorough testing, quality control, and user feedback became standard practices in military aircraft development. The technological innovations pioneered in the Helldiver internal weapons carriage, advanced hydraulic systems, precision attack capability became standard features in subsequent military aircraft. The aircraft had pushed the boundaries of what was possible with 1940s technology, creating a foundation for even more capable designs. The human legacy was equally important. The thousands of pilots, crew members, maintenance personnel, and factory workers who had contributed to the Helldiver program had gained experience and expertise that would shape American aerospace development for generations. The training programs, maintenance procedures, and operational techniques they developed became models for future programs. As Morrison's SB-2C touched down on Valley Forge's deck for the final time, it marked the end of an era in naval aviation. The age of specialized dive bombers was ending, replaced by multi-role aircraft capable of various mission profiles. But the lessons learned from the Helldiver service, both positive and negative, would continue to influence military aviation development. The statistics told part of the story. Over 7,000 aircraft produced, participation in every major Pacific War engagement from late 1943 onward, responsibility for sinking more enemy shipping tonnage than any other Allied dive bomber. But statistics could not capture the human drama of developing and operating such a complex aircraft under wartime pressures. The real measure of the Helldiver's significance lay in its contribution to Allied victory in the Pacific War and its influence on subsequent aviation development. Despite its troubled beginnings and ongoing challenges, the aircraft had proven that American industry and military personnel could overcome seemingly insurmountable problems to achieve success. The Curtiss SB-2C Helldiver had earned its place in aviation history not as a perfect aircraft, but as a powerful demonstration of American determination, innovation, and adaptability under the pressures of global warfare. The beast had been tamed, and in the process, had helped secure victory in the Pacific and established precedents that would guide military aviation for decades to come. As the last Helldiver was struck from Navy rolls and relegated to museum display, it carried with it the legacy of all those who had contributed to its development and operation. Their story remained as a testament to the complexity of modern warfare and the human spirit's ability to overcome seemingly impossible challenges in pursuit of larger purposes. The 880 modifications that had been required to make the Helldiver combat-ready represented more than just engineering changes. They symbolized the trial and error, dedication and sacrifice, innovation and perseverance that characterized America's World War II aviation effort. In the end, those modifications had produced not just a better aircraft, but a better understanding of what it took to develop and operate complex military systems under the pressures of global conflict. The beast was gone, but its lessons lived on.